Hello, everyone. I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University. And in this video, I'm going to briefly go over some of the basics of geospatial application that I'm very much used to running, and that is the multiscale geographically weighted regression. So let's get started. Um, for starters, before I even got to this step where you're seeing this python-callable program that has been developed by Fotheringham and Sachdeva, and there's been multiple iterations of this software. But before I even got to this stage, so I actually ran some merging between county health rankings data, which are very important socio-demographic sort of indicators at the county level. And so there's a lot of composite sort of measures that are a part of this data set, which I really urge you to not only explore within their website, but also look at all the different variables that are available within this data set. There's some examples of these variables within this variable list, but I can't really comprehensively go over all of them. Why it is also important is because something else I want you to keep in mind with county health rankings is they have a very uh, exhaustive sort of framework where there is a contribution of not only health care, but also preventative measures, and what are the relative percentages of contribution of each towards overall health. So it's a really powerful geospatial resource county health rankings, which is why I'm going over this a little bit. Um, but enough of discussing about some of the theoretical aspects. Now let's get started in how we can apply this. So let's take a look at what I did I merged the county health rankings with some cancer indicators and different health indicators. And this is something you can do as long as you have the FIPS code. You can merge multiple data sets. So FIPS is here, right here. So for ID, it's optional, object ID, that's a good one to kind of include. X and the Y, this is a little tricky. So the longitude and the latitude is the centroid, is kind of the center of where each of these counties or each of these locations are there. So that's the exact longitude or latitude of the center. So these have been designated per each FIPS. So this is why we can say X is longitude, and then Y is latitude. And then, what is a potential sort of health outcome that you want to be looking for? So what is something that is um, important to look at? So maybe percentage with alcohol driving deaths, right? That might be something that is good to look at. So there's multiple outcomes that you can be trying to understand. So there's also firearms. Um, so there's so many options, and you can actually select any of these as a potential dependent variable. So I think one that might be something that is interesting and important health outcome is HIV. And this is something I have experience from seeing patients within clinics, but also doing a lot of research within data sets. So It's something that is important and really connected to um, equity related issues. So this is where we can kind of look at insurance as a really powerful sort of indicator. So the percent uninsured, unemployment is something that is percent unemployment, also percent education, and so on. So we can kind of run a simple sort of um, model here, and then name it um, a name that you might remember. So I might name this as the date today, and then just save it. Select save. They might ask you to save it somewhere else. And then make sure you know where it's being saved and then select run. So you should see this. And so just a word of caution here when you're running this, um, don't expect to run this right before a meeting. Give it some time. The last model that I ran roughly had 6 independent variables and actually took over an hour to run. So these are pretty memory intensive sort of steps. So if you have a computer that is powerful, has a lot of RAM, then you can expect this to run a lot more quickly than if you have a computer that doesn't quite have as much RAM or powerful processing unit. So you'll in the discipline of machine learning and more computationally intensive types of techniques, you'll find people discussing about the issue of types of processors, strengths of processors, and the types of memory that is needed to process these. So a lot of things to be considering when you're running geospatial applications. And so once you get the output, then you're able to not only compare the types of models with geospatial variations and without, but also see how well these models ran through the Akaike information criteria. And I've lectured on this part in some of my other videos. Thank you for listening.